I just like to mention that this is the hourly and accumulated rainfall for a Pakistan area. It's continue about 1 day. The hourly rainfall is more than 60 millimeter. So they produce very large daily rainfall, particularly at this mountain station. So I will talk about a little bit on how the Central Weather Bureau make the typhoon rainfall forecast. We are based mainly on analog and climatology approach. For the analog approach, the Central Weather Bureau already collect quite a complete historical data set and also make those data set accessible on computerization system, so the forecast can pretty easy to find the analog the similar typhoons during the past. For example, for the Morakot cases, with search for similar cases, they can have the all those checked like this diagram show. They have several 50-something typhoons. They have a similar track as Morakot, and they produce a list, a table listing to show the names of typhoon and also to show the difference between the Morakot and the selected typhoons. So and also the forecast can see the previous rainfall distribution on different typhoons. You will find that some of the rainfall distribution are kind of similar to the rainfall distribution of the Typhoon Morakot. There's more cases, so the forecast will view each of those cases. And also some climatology average method was developed in Central Weather Bureau. For example, they just this diagram just show that if typhoons are located somewhere here related. For example, this is the background is show the location of Taiwan. So if typhoon center are located at the north east of Taiwan, the rainfall distribution will look like this diagram show. So the computerized method also developed by the Tien-Chiang and the applied at the Central Weather Bureau. This diagram just shows some forecast based on, for example, starting from here, the Central Weather Bureau to predict the track will follow this track in 120 hours. Then they run the model to show that if the tracks are going like this, then the major area rainfall will be on the northern part of Taiwan. And some more forecasts from different, starting from different time, they have the rainfall distribution like this. So there's more, for example, at this time the rainfall is heavier than the previous because now the Central Weather Bureau has more accurate estimation of the speed of the system. But from the because those results are from the climatology average, so you can expect that those values will much less than the Morakot, the actual rainfall on Morakot. So in summary, actually the Central Weather Bureau forecasters will look at all the analog cases, the climatology mean values, and also they look at the numerical model forecast and some estimation from satellite images. So and come up to the kind of up part because each forecast will have a different subjectivity modification based on those guidance and make their own forecast. And this diagram shows the the first rainfall forecast, it is about 4 days period to the whole process of the Typhoon Morakot, because the whole rainfall event is about 4 days. But this forecast is kind of 4 days earlier issue this forecast. So the Central Weather Bureau, this is the actual accumulated rainfall that the maximum here. But over this side is the Central Weather Bureau's forecast. They have predicted the maximum rainfall is about 800 mm. Although it's relatively small compared to the actual occur, but the general pattern is quite similar. You have a heavy rain over the southern west part of Taiwan and also the central part of Taiwan and also the northern part of Taiwan. But we found that's kind of underestimate, particularly over this part of Taiwan, because in the previous cases, because there is mountain here, we expect it should be the downwind side of the mountain, should be the dry area. But in this case, some of the rainfall was able to move over the mountain to the east side of the mountain. And another overestimate area is on the northern part of Taiwan. As you have seen from the previous talk, this system is very anti-symmetric. The rainfall is small in the center area, so we have overestimate over the rainfall over the northern part of Taiwan. So I have to go quick because the time is limited. This diagram just shows you the Central Weather Bureau was able to update their forecast when more observation was available. And this diagram shows you the observation rainfall like this, and these bars represent the Central Weather Bureau's forecast. The lower bound for this station, for this area, and the upper bound of this area. They modified the forecast. Originally, they are from about 500 to 800, and for about 700 to from 1100. So it's the Central Weather Bureau's forecast. From this forecast, actually, you can see that if we talk about the leading time of warning, for example, 800 millimeter rainfall is actually occurred here, but our forecast is here. So this representing the leading time of the warning. This is about 30 or more than 30 hours of leading time for this warning. And this diagram summarizes some of the leading time of the rainfall forecast. For example, over this particular area, its leading time is more than 5 hours. And for some of this area, they can see from the length of this area is representing the leading time of the forecast. So only some few area, particularly over the east side of this mountain, we have underestimated the effect. So we have the less leading time. For overall, the leading time is generally more than 11 hours. I will skip some of the detail of what we have tried to improve our forecast system